Namaskar everyone, my name is Naveen Kumar and I am faculty of physics at Rawat Public School. Now in today's video we will discuss about the chapter number 3, that is motion in straight line. Some of the terminologies that we are going to discuss in this chapter, that is of 11th class, scalar quantity and vector quantity. Okay, so what are the scalar quantities and what are vector quantities? Scalar quantities are those quantities which are having only magnitude, magnitude means numerical value only. Those quantities which are having only numerical value are scalar quantities. Okay, just like as distance, mass, time, temperature, and etc. Many scalar quantities are there, okay, which gives us only a magnitude. Okay, whereas in the other hand, vector quantities, they are having magnitude as well as they are having direction. Okay, magnitude as well as direction, they are giving both. Magnitude means numerical value and direction means up, down, positive, negative, okay, push or pull, likewise. Okay, these are the signs of direction. That means these quantities gives us a sense of direction. Like force is a vector quantity, so we are specifying 10 Newton, let's say. It is not giving us sense of direction, okay, but there is an inbuilt direction. 10 Newton where? In the opposite direction or in the direction of the person who is applying force, maybe upward, maybe downward. That is, it is giving you a hidden sense of direction. That's why it is included in vector quantity. So examples for the vector quantities are displacement, okay, that is velocity, acceleration, the force that we discussed right now, force, and many more are in the vector quantities. One of the very important thing, that is work, that is a scalar quantity. Okay, current, is a scalar quantity. Area, most of the students get confused in it. Area is what? Scalar or vector. So area is a vector quantity. Don't confused about this. Area of which direction? Area of cross section, area of volume, or likewise many things are there. So area is a vector quantity, and work, current, energy, pressure, all these are the scalar quantity. In fact, there is another category in which the quantities are both, and that is tensor quantity. Tensor quantities. In these quantities, they are representing both scalar as well as vector. Let's suppose that is pressure. That is considered as scalar, or sometimes it acts as a vector quantity, but it is a tensor quantity, we can say. Okay, just like as current. This is a tensor quantity because direction matters in current as well. Say at this junction, 10 ampere current is coming. At this junction, 2 ampere current is coming. Okay, so how much current will go here? That is 12 ampere. Okay, now what if I change the direction? It is going in this direction. So what will happen? The amount of current which is going in this direction is 8 ampere only. Okay, that means direction of current matter here. Okay, so current is a vector quantity. As we can see, the current is a vector quantity, but current is included in scalar quantity, so it is a tensor quantity of rank 1. Okay, so rank 0 only, because the tensor quantities, if their rank is 0 degree, then they comes in the category of scalar. Okay, if the rank is 1, then they comes in the category of vector. Okay, I hope it is clear for tensor quantities. If the rank is 0, then they comes in the category of scalar. We can call them scalar. Pressure, current, okay, all these are of rank 0. Okay, and if the rank is 1, then purely they are vector quantity. So those quantities which are coming into the category, that is both scalar and vector, then we can count them in a vector quantity. Okay, the tensor quantity. So it is important to represent a vector quantity. Like scalar quantities, we can write A, B or any of the name. But in case of the vector, if you want to represent a vector, then we need to put an arrow over the head of the quantity. So it is a vector quantity now. Now F, that is force. This is vector quantity. So we need to put an arrow. Okay, so all the vector quantities are having arrow on their head. Okay, so this is about scalar and vector. Let us discuss some more terminologies related to motion in straight line. Okay, next thing related to motion in straight line, that is path length and displacement. Okay, now the path length is the actual path traveled by the object, is a path length in a given specific time. So let us understand it with an example. That let's say is our object started from A, it moves to point B, then to point C, okay, and then it moved to the point D and returns back to point C and point B, and then again reach to the point C. Okay, now what will be the path? What is the path of the object? A to B, B to C, C to D, then D to again C, and then to B, and then again to C. This was the path of the object. That is increasing, decreasing, increasing, decreasing. Okay, now what we are seeing, path length, that is the actual distance, actual path traversed by the object in a given time interval. Now let's suppose all these distances are apart from each other with 5 km. 5 km between A and B, 5 km between B and C, okay, and 5 km between C and D. Okay, now see, A to B, 5 km object traveled, B to C, again 5, C to D, again 5, D to C, again 5 km. Okay, same way it returned from C to B, that is 5 km, then B to C went back 5 km. So how much total distance the object has traveled? That is the path length. 5, 5, 5, 5, 5 and 5, that is 30. Object traveled 30 km in a given time interval, irrespective it returned back or went back somewhere at point C or D or B. It doesn't matter. The direction of the object doesn't matter. Only what path it has traveled during the journey in a specific time period, that is known as path length, actual distance traveled by the object. Now let us discuss the displacement. What is the displacement? Displacement is the shortest distance between initial point and the final point. This is the shortest distance between initial point and the final point by joining a straight line. It is not like this object is going from A to C in this path and A to C this path. Out of these two paths, AC is shortest, so it is a displacement. No, displacement is always in a straight line. So Displacement is the shortest distance between the initial point and the final point joining with a straight line. So in this given example, let us say object was traveling in this path. So here what is the initial point? A. This is the initial point. This is the initial point. And what is the final point? C. This is the final point. Okay. And what is the distance between A and C here? A is, let's say, the 0 position, and C, the distance between A and C is 5 plus 5. This is only 10 kilometer. You can see this is distance and this is displacement. Now I hope it is clear what is resistance and what is displacement. Now one more thing, actual path length we can call it as distance. Unit of distance is meter, unit of displacement is also meter, but distance is a scalar quantity. This is a scalar quantity and displacement is a vector quantity. Okay, scalar quantities, they can be 0, they can be positive, and these vector quantities, they can be negative, they can be 0 and they can be positive. So I hope it is clear about distance and displacement, scalar and the vectors. Okay, thank you very much.